Hey everybody, Jim here, coming to you not live through my brand new YouTube channel. This is actually the first video on the channel, so please click subscribe, and in the future I hope to take you on some software tutorials, we'll do some product reviews, I've got some tips and tricks that I can teach you, and you get to see my projects as well. So thanks for joining, let's get started. Today we're going to talk about the Moai Resin 3D printer. It's a Kickstarter campaign that's happening right now. It's actually already successfully funded and there are a few days left in the campaign. It's a laser galvanometer style resin 3D printer. So if you're not familiar with resin printing, instead of melting plastic, it starts with a resin like this. It's a liquid. You can see that it's got a viscosity kind of like motor oil does, and there's a photo initiator in this UV resin that when exposed to ultraviolet light, photo develops it or cures it into a solid. So you pour this liquid resin into the printer, the laser and galvanometer system will raster the shape of each layer into it, and that's what photo develops it into a solid for each layer to successively build into a 3D shape for you. So I think the best way to demonstrate how it works is to actually do a demonstration print, so let's do that. It begins with the build vat. On the Moai you've got a 13 centimeter square build vat. It's built out of acrylic, and on the base it actually has a material called PDMS, which chemically is very similar to silicone. So you've got a clear silicone layer, a squishy rubber layer on the very bottom of the vat. You pour in liquid resin so that you're aware resin is an irritant, so you want to avoid coming into contact with it. It's always a great idea to wear gloves, and if you're going to be pouring it or doing anything that risks splashing, you'll want to wear safety glasses as well. So, you take your resin, you want to make sure that it's stirred and agitated, that way that the color and pigments that are inside of it haven't settled out of it. You pour it into the vat so that it reaches all the way from one side to the other, and you'll get less bubbles if you're higher up, but you also risk splashing a little more. So that's pretty good. We'll put the lid back on. So you can see the resin is in the vat. It is a liquid, it swishes around. Let's put it into the printer. You can open the door on the printer, and the vat goes down here on the bottom. It slides in, you can feel a spring detent where it needs to stay, and then the build plate goes in next. Now, one note about the build plate, you never want to have this installed if the vat isn't installed, because resin could drip off of this and damage the galvanometer mirrors. So always make sure that this goes in last. Slides onto this arm at the top. There's a little thumb wheel to tighten it, and then you can turn the printer on. So anytime that you have the printer on and the door open, you'll want to protect your eyes from the laser that's inside of the machine. It uses a laser diode that's 405 nanometers, so make sure you have a pair of laser safety glasses that are appropriate for that wavelength of light. After you're safe, you can start a print. Start by clicking. You can select a folder, then you scroll to the file that you want to print. That one will work. We click OK. It wants to confirm. We click again, and now we'll start the print. So right now it's homing the Z-axis. It's also going to make sure that the vat is zeroed out and is completely flat. Then it'll lower the build plate into the vat to Z0. So there will be one layer thickness of resin between the aluminum build plate and the clear vat. It tilts to evacuate any built up pressure just to make sure. And now you can see the laser line is actually solidifying where we want. So after it's done curing this layer, you'll see the vat floor tilt down to peel the printed part off the PDMS layer. Then it'll reset. You'll see the Z-axis move to the position for the second layer. It'll cure that layer, then it'll peel, then it'll position, then it'll cure, then it'll peel, then it'll position, and one after another, that's how it successively builds up layers to form a fully printed 3D object. So you notice that after the first layer it speeds up. It overexposes the first layer on purpose to make sure that it sticks to the aluminum build plate, and after that the machine moves pretty quick actually. So after a print is completed, to get the print out of the machine, I've actually found that a paper plate is a neat trick. It'll fit right through the door, You can unscrew the build plate and pull them out together to catch all the drips. You can set the build plate up vertically, and then either using a plastic scraper or a razor blade, you can remove the printed part from the aluminum build plate very, very cleanly and without gouging the aluminum. After you have the part off the build plate, there's still a little bit of cleanup to be done. There's going to be liquid resin clinging to the outside surface of the part and in the little cracks and crevices. So it's a good idea to swish these parts around in an alcohol solution or with soap and water to get the rest of the resin off the outside of the print. A good part coming off the printer still needs to be cured just a little bit. The right thing to do is to either set this in a windowsill, to put it outside where it'll get sunlight, or to use a UV lamp to fully cure the part after you're done. So let's talk about the advantages and disadvantages of resin printing. The most obvious advantage is being able to get super intricate, really fine details out of it. Right now I'm printing at 100 micron layers. That's about half of what I normally do on an FDM machine. There are people that have gone as low as 25 or even less than that to get really fine layer height. One of the other advantages is that you're not fighting temperature, so all the melt and the sag and the bridging and the overhangs and the things like that you're fighting temperature and adding fans and doing things like that to fix with FDM printing, you don't have to worry about here. One of the advantages in particular of the Moai printer is that it uses sliced G-code from Cura, so you may already be familiar with the workflow that it takes to run a print through this machine. Disadvantages are working with resin. It's a little bit of a mess. When we poured resin earlier, we had a pretty clean time of it, but you'll always want to make sure that you've got rubber gloves around. You always want to make sure that you've got paper towel around. You'll need to have somewhere that you can put excess resin. You'll have to treat it like you're working in a laboratory to safely and cleanly work with the resin. So I've had this pre-production beta unit for about 3 weeks now. I've been running it pretty constant, and I'd have to say I'm really impressed with it so far. I can get really fine details out of my prints. It seems to be accurate and repeatable. It's reliable. I have less failures than my other machines. I've done some torture tests like this stepped cube. This thinnest width right here is actually 1 laser line thick, so it's actually a slicer test as well as what the laser and galvanometers and material properties of the resin are capable of. I've done things like that. I've got some of these calibration cubes that have really tiny letters on top, so it's a good way to test infill overlap and some of those things that you might be familiar with from the way that your slicer works. I'll post some pictures of the parts that I've printed, especially some macro shots where you can see the layer lines and some of the artifacts that you get from this kind of printing. They're really minuscule, and I think you'll be impressed by the fine details you can get. And so far I'm really impressed with the machine, actually. There are certainly some improvements that can be made, but I think a lot of the improvements are going to be in the printer profile, the slicing settings, and the soft side of it. I think the machine is there. It's in tuning in the slicer, making sure that the speed and the intensity and all the slicer settings are correct to get perfect prints out of it. So I'm going to keep working on that as part of the community. I hope some of you join on too, and it'll be really exciting to see where this goes. So if after all of this you're still asking yourself, is this the right printer for me? I think it comes down to 2 basic questions that you should ask yourself. The first one is, do you really need to print parts that are finer resolution and a higher detail than what FDM printing can already offer you? And the second is, to get those results, do you mind wearing gloves and safety glasses and treating your printing like you're working in a laboratory so that you can get the results you want while you're clean and safe around the resin? It's annoyance for some. For me, it's a small price to pay. It's going to vary person by person. So if you don't think you'd mind resin printing and you really want the high detail prints, I'd strongly encourage you to consider this printer. It's certainly the first one that's been in this price category for a laser galvanometer machine, and I've been thrilled to have it the last few weeks. I'm really impressed with the results I get out of it, and I think that you'll like it too. Mark has a nice product. So, thanks for watching. Let me know if you have any questions in the comments. Again, this is my first video, so if you have any suggestions, please let me know down below, and I'll catch you next time. Thank you.